Thank you, and I'd like to start by welcoming everybody that's joining us today from wherever in the world you're from. Good morning, good afternoon, good evening. It's always great to have you join us with our webinars and helping to learn more about encapsulator technology and all the benefit it brings to the different industries. My background has always been in fire safety in some form or another. I've got 38 plus years in dealing and looking at and trying to help fire departments and help people put out some of these high hazard fires. And today what we are going to be talking about is going to be auto recyclers, and we've currently become members of the Auto Recyclers Association. So we're hoping to work with them a little bit closer hand in hand. And this is kind of the first step in helping them to understand just exactly how hazard controls can help them out and with some of their hazards that they faced. And as part of our mission, as you know, like my goal is to try to make fire protection in industry within the communities and basically all around the world a little bit safer. We want to try to do eco-friendly. We hear a lot of things in the news nowadays about the fluorinated foams. So we're trying to show that we've got some new innovative technology, basically, as I say, 21st extinguishing agent for 21st century fires. So I hope to give you a little bit more of a background to give you more information about hazard control technologies. We are based in Georgia, Fayetteville, Georgia. We've been around since 1997. So we're not just a startup company. We've got many years behind us, a lot of environmental studies, a lot of technical and testing that's been done throughout that time. We're a global distribution network. We're all across the world as far as offering these solutions. So it's not just here in the United States. So today, my objectives are going to be dealing with how this technology can work and be a benefit to the automotive recycling industry, and how we can help working with your local fire departments and reducing the amount of time and maybe reducing the amount of water and being able to mitigate any incidents where you have fire much safer. We're also going to be talking about, and I hope to help you understand, because as we go through this, it's going to be talking about spherical micelles. And I hope to give you a better understanding of what a spherical micelle is and how it works. And then we're going to show how the encapsulator agent works on all four legs of the fire tetrahedron. Basically, some fire terminology that we help understand, and we understand that, you know, if we have an effect on any one leg of the tetrahedron, we can basically have a great effect on being able to extinguish the fire. And then identify some of the equipment and some of the things that are going to make it so that you can use it. So when we sit there, we start keying in on the automotive recycling industry, you know, we can sit there and start looking at all the hazards. And it covers many different classes, covering class A, you know, because you have the fluff, the materials, some of the soft stuff. Tires fall into the class A. We get there and get into the class B materials, the diesel fuel, the oils, gasoline. And then we sit there and start looking at the class D metals, the magnesium, titaniums, or any other hazards. But the new and up and coming issue that we're faced with is lithium ion battery hazards. And even though we may not have a hybrid vehicle, or we may not have a battery powered car, there's been many instances that I've heard people talk about where, you know, maybe a vehicle was involved in an accident. Maybe a laptop had been left in the car, maybe a cell phone. Something might have been left in the vehicle. And in the process thereof, as it was shredded, you know, that battery was affected, failed, caused that spark, and in some instances, fires within the recycling centers. So, you know, these class D metals are becoming even more prevalent in vehicles. I think last year I was doing some research on the amount of basically magnesium in an average vehicle, and somewhere in the area of about 350 pounds. And in trying to get an understanding of why auto manufacturers are using so much of the magnesium in a vehicle is, as I continued to do some research, we know that auto manufacturers are trying to make cars lighter. So that 300 pounds or 350 pounds of magnesium can help reduce, I believe it's 500 pounds of steel and 150 pounds of aluminum. So they're reducing the weight by 650 pounds by using 300 pounds of magnesium, about 350 pounds of magnesium. So it is helping to reduce the weights of the vehicles, and hopefully by doing so, increasing our fuel mileage and some of the things that they're trying to accomplish. So the other thing is we need to sit there and start looking, because as this continues to evolve, the big push is for lithium ion batteries and battery powered vehicles. So you're going to start seeing more of these hybrid vehicles in these recycling centers. And I know myself personally, when dealing with some of these, many of the recyclers, they require that, the fuel tanks be removed before the cars arrive. But yet, there's one that sneaks in where, the fuel tank wasn't removed, and there might be just a little bit of fuel left in it. And when it goes through the shredder and gets chopped up, we know that we can have some not so pleasant results. And when we sit there and we start getting these fires, if they're not caught early on, they can spread quickly, they can spread rapidly. And we know from other presentations that we've done and we've talked about, when we're dealing with these types of fires, as you can see, this is a three-dimensional fire. It's got height to it. So when we sit there and we look at the amount of water that's being used, or if they start using foams, we, from our previous trainings, have talked about how foam is not suitable for a three-dimensional fire. And if we go to NFPA 11 and the Annex A11 of that standard, it even states in that standard, foam is not suitable. So when we come and we start throwing and using and trying to extinguish a fire like this with foam, it's not very effective. Not very effective at all. So in this presentation, I hope to give you a better idea of just how effective, by adding an encapsulator agent into your hose stream, it can make and help reduce the time firefighters have on scene. Now, this is a thermal imaging and actually some video. This is of a fluff pile. In the thermal imaging, this is being monitored and being watched. The thermal imaging camera is monitoring this particular device. That's we work with Fire Rover, and what's happening is they've charged the tank, and now what they're doing is they're starting to extinguish this fire. They're starting to address and starting to have an attack. They're getting it before it has a chance to really start to grow in size and to have a huge effect and impact on the facility. I'm going to speed through here just a little bit because, as they're sitting there and they're having an effect on this fire. Oops, what the heck? I'm sorry. They're having an effect on this fire. You're going to see some of the employees are going to start coming into view here off to the side or in front here. And they're on their radios calling for equipment, maybe to start to spread that pile out just a little bit and do what firefighters call overhaul. They want to make sure that they've got to the seat of the fire, that they're able to have this extinguished, and that it's not going to grow. The nice things about systems like this is after hours, after employees go home, this is a 24-hour, 7-day-a-week protection system where, if employees are at home, there's nobody there unless you have guards or some type of a security force at this particular facility or your facility. There's nobody there. So these are ways that you can use to protect your facility after hours and on weekends or whenever your facility is closed. And as you can see now, they're starting to dig into the pile. They want to make sure that they got into the hot spot, the thermal imaging. As you can see now here, again, you see the people standing there. So this is, real-time thermal imaging, and you can see that the hot spot has been pretty much removed, and this fire has been extinguished. It's no longer going to be an issue. So when we sit there and we start looking at these incidents and the statistics, if we look at this report, the report is showing in here the fires in the US and Canada at some of these recycling centers from February of 2016 to February of 2020. And you'll see how the um, rates go up, and they go up a little bit higher during the hotter months. You figure when the temperatures go up, so does the ability for these recycled or these products to hold their heat within them. So it does just create some additional issues as those temperatures rise up. And like I say, when we sit there and we go, you see the report that again will be on this recorded version, so you will be able to see it. But it's going to give you some very good summary information. So please, when you get the copy, take a few minutes and spend some time going through this basically hyperlink and learn a little bit more. But when we get into the nitty gritty of this report, it starts talking about within a 12-month period in the recycling industry, there are 348 reported cases of fire incidents in these facilities between the US and Canada. And, that's quite a few when you sit there and you start to think about it. But the thing that really starts to highlight some of these are the injuries that occurred. The reported injuries, 52, but even more disturbingly is the 5 deaths. That's, to me, 5 too many, and even those injuries. So if we can sit there and offer recycling industry some solutions to help prevent these deaths, these injuries from happening, especially currently with today's high heat, we're going to talk about, the high heat that's basically affecting countries all around the world right now. So we'll talk more as I go through, but the whole point is we can sit there and we can show you how we can help reduce these fires, make them smaller, using less water, less manpower, less fatigue, less stress, and how we can have an effect on these hazardous materials that are now inside of our vehicles. And how we can sit there and how we can work on being able to extinguish that 3-dimensional fire that I talked about earlier when you saw the picture with that huge fire. And I mentioned that foam's not suitable. We're going to talk about how encapsulator technology is able to and will have an effect on being able to extinguish that 3-dimensional fire, and how it's going to work on those lithium-ion batteries. So we're going to talk about the innovative technologies, the solutions, and I'm going to actually start getting into an NFPA standard. It's NFPA 18A, and I'm going to get a little bit more specific because as we sit there and we start talking about the spherical micelles, that section 7.7 is going to encompass or talk about the spherical micelle stability test. The other portion, the point I'm going to start to make, and we'll talk and we'll see it later on also, is in NFPA 18, that Annex 4.3. Again, some very important information that's covered in that standard that we'll see as we continue on in the program. But I just want to make a point that, there's some information in this NFPA 18A standard that is very, very useful and really keys in on how this product is going to be a benefit to the recycling industry. Because as this slide shows, you're dealing with all of these hazards. You're dealing with the Class A fires, as I mentioned earlier, with the tires, the seats, and all the plastics. You're dealing with the Class B, the fuels, the Class D metals, the titanium, and the lithium-ion battery hazards. So as we talk about the Class A, and I'm going to probably use this as the best example, and I'm going to hopefully, as I go through and I discuss how the agents work on dealing with the 3-dimensional fire, I'll be showing you a video and pausing it and talking and just discussing just all the key points that I feel are important in helping hopefully you to understand how this agent is able to benefit this industry. And as we go through, we're going to learn about how, the toxins, the smoke, the soot, and the gases that are being released during these fires that are going to possibly cause neighborhood evacuations, how we can reduce that, how we can eliminate that and keep people in their homes. So as I go through these next few slides, like I say, I'm going to be talking, especially this one. This is the one I'm talking about that I'm going to be pausing and discussing. And it's a real good one because F500 has been used on two of the largest tire fires in North America, Watertown, Wisconsin, and Gila River, Arizona. Now here, this one is in Panama. And the reason why I'm going to key in on this one is because while we were able to put those two large fires out, we didn't have a comparison of water versus F500. This one's going to give us that comparison. Okay, and that's what I want to talk to you about. And that's why I'm going to be pausing it and pointing out some things. Some what I feel are important. Here they use a total of 18 pails or 90 gallons of concentrate, okay, to work on being able to extinguish the fire. Yeah, it might seem for some that it's very costly, but as we go through here and as I continue to pause and talk about it, let's see if it really was that expensive. A lot of people like to make those comparisons up front. So I'm going to pause this again. And, as we sit there and we start talking about the recycling, I'm sorry, it paused on me. Instead of pausing, it went backwards. Anyway, it was donated. They put it into the trucks. And as you can see, they're batch mixing it. They're not trying to deduct it. They're just very simply batch mixing the product, which is done. It doesn't need to be agitated afterwards. And the things that I really want to highlight here is one, the time. Okay, 42 hours with plain water versus 2 hours with F500 at 1%. It's a 40-hour difference. And as I go through and I continue on with this presentation, I'm really going to start to make an issue of just what that means. Okay, man hours, 420 man hours, 10 firefighters, 42 hours. Okay, then we get to the F500. It shows 10 hours. Oh my gosh, what a difference in manpower cost and the stress and wear and tear on your firefighters. So we have a difference of 410 hours just in our man hours. On a hot day like today, we can be rotating our firefighters out. We have 2 trucks with plain water and 1 truck with a 1% solution of F500. So we're using actually 1 truck less when we're sitting there and we're using an encapsulator agent. And you know what, that's going to be coming up here pretty important to me when you sit there and start looking at this. Okay, here we got again the 10 firefighters versus 2 on these hot days. All right, I keep hitting the wrong button, sorry about that. So when we sit there, we start getting into this, it makes a huge difference as far as our manpower and our cost, our labor cost. We look at the amount of heat difference that was able to be absorbed by plain water. We're looking at like 6.6 million kilocalories of heat an hour that's being able to be absorbed. Water is very poor at being able to cool. And then we put that 1% solution of F500 on that, and we're now reducing the absorption, the heat, or increase, I should say, the heat absorption to 63.3 million kilocalories of heat. It's almost a 10% increase, okay, in being able to reduce the heat. And now as I continue on, I want to point out that when we sit there and we look at the water, how many areas in the world are experiencing drought conditions? Do you have an extra 39,000 gallons of water within your community, in your town, where you can sit there and use it to extinguish some fires, tires? So the resources that are being saved when you sit there and start looking at the difference between plain water and F500 are huge as far as the time savings. But the thing that I really want to highlight when we sit there and we start getting into looking at the difference is when I sit there and I go back to this 84 hours and the 2 trucks and so on and so forth. I took a few minutes and I did some calculations because you always get those people that are worried about the cost. of F500 or the cost of a solution to put into your water. And when I sat there, I started to look at this, and 2 trucks, 42 hours. So that's 84 hours for 2 trucks versus, 1 truck for 2 hours. So we have a difference of 82 hours. So if I sit there and I do some quick calculations, and I just use a simple $4.50 a gallon for diesel fuel, and I do an assumption that those trucks are going to use somewhere in the area, maybe I think I estimated somewhere about an average of 5 gallons an hour per truck. You're looking at a cost of about $1,890. That's a lot of money. But now when I sit there and I look at 1 truck for 2 hours, I'm looking at $45 in diesel fuel. It's considerable savings. So, when we sit there and we start looking at some of the advantages of taking a few minutes and looking at how much of a difference it makes, not only in being able to extinguish the fire, not only in being able to reduce the soot, the toxins, having less environmental impact, needing less water, but now, again, less wear and tear on the firefighters, less wear and tear on the fire apparatus, and a savings to the community, especially with diesel costs being as high as they are. So we sit there and we look at these hazards along the roadside, the Class B fire hazards, and how, F500 also has an effect on the Class B, the fuels, the diesel fuel, the gasoline, the ethanol. If you have some of your E85 cars or some of the others, how we can have an effect on being able to mitigate these, where I can give examples of a fuel spill at a facility that used foam. Because of the heat of the day, how hot it was, they had to reapply foam every 6 to 7 minutes because it was evaporating away. Yet when they sat there and they came in and they started running low on their foam, they used the encapsulator agents, the F500, and they sprayed that same area that had been retreated with foam. Now they come through and they use the encapsulator agent on it, and they let it sit for 20 minutes. And at the end of 20 minutes, they get their gas monitors out, their 4 gas monitors, their LEL detectors, and they start combing and walking the area, and they find 0 LEL. So the next day they have a cleanup contractor come in, the EPA, other organizations, and they sit there and they start walking the area, trying to figure out where they need to do the environmental cleanup. And you know what? There's no sign that there was ever a spill there. So it even reduced the cost of those cleanups. Class D metals, as we talked earlier, big hazard. And the reason why they're a hazard is because of the temperatures that Class D metals burn at. They cause a water molecule to break into its 2 properties, hydrogen and oxygen, creating an explosive atmosphere, which is why we see those huge explosions when we sit there and we start hitting magnesiums and our Class D metals with water. And as we see, and as I continue on, you're going to see how by using an encapsulator agent in your water stream, we change the makeup of the water droplet, and we have a huge benefit when dealing with these types of metals. And we look at some of the common components of the vehicles, your dash, with steering wheels, steering columns, some of the the seats, seat frames, transmissions, transmission housings, and just all kinds of parts are being made. And you know what? They keep adding to them. They're making support struts and support columns in different parts of the vehicle. Again, using these Class D metals because they're lightweight and strong. They give a lot of benefit in being able to make the car stronger, but yet lighter weight. And then our new hazard, our lithium-ion batteries, which is growing. In the news, we always hear, when we sit there and talk about lithium ion and we start talking about cars, it's always Tesla. Okay. But you know what? They're not the only ones. We've got high-lows. Okay. We've got service equipment at airports, ground equipment, ground support equipment, those little tugs that push planes around and move the luggage around. We've got trucks, we've got buses. Okay. We've got school buses. The market and the diversity of lithium-ion batteries is growing, And you're seeing pretty much any mode of transportation going that way. Even train engines, they're getting into everything. And when we sit there and we start hearing about these batteries, we hear copious amounts of water. And I'm going to throw out there again that big fire with the tires, and being able to save 32,000 gallons of water. We have stories of Teslas needing 30,000 gallons of water. What is a copious amount? And I know throughout my career going through and dealing with all these many different types of high hazard fires, I've heard that terminology many times. And, a copious amount of water could be anywhere from 100 gallons to an infinite number of gallons. And again, with many areas of the world experiencing drought conditions, do we really have that much extra water to be able to use on one fire? So we're going to start with a real quick comparison. This particular video comes to us from Kiwa Labs. It was done on behalf of our European HCT office and Johnson Controls. And what they are doing is they're looking at a comparison between foam, powder, and F500 encapsulator agent. When I show this, one of the things I like to also highlight, because I do some other videos and I do some other trainings, but when we sit there and we start looking at this lithium ion battery hazard in dry powders, those ABC extinguishers, what's the extinguisher that's required by code in all of our buildings, our warehouses? It's that dry powder. And you can see how very ineffective it is. He's using an almost constant spray. You look over here with the foam, almost a constant spray. And you can see, and as you watch the video, he was just using short little, blast with the F500. And the F500 was able to extinguish the battery and stop the thermal runaway. But yet was able to do so much more. And I'm going to go back here just for one more time, just for 1 second. I want to play it back and I'm going to stop here because as you can see right here, the gentleman in the powder shot, not wearing an SCBA. And we're going to talk about that a little bit because of the off-gassing that's caused by lithium-ion batteries when they burned. This gentleman was part of 3 days of testing. And at the end of the 3 days, because of the HF gases that he was exposed to, while these batteries were being burnt for this test, he spent some days in the hospital detoxing because of his exposure. So, very important that if you're going to be dealing with this type of a hazard, you have the right agent, you have the right training. And the right agent I'm going to talk about right now is encapsulator agent, F500. And we're going to see why. First off, the question might be, what is it? Well, it's a fluorine-free, it's non-corrosive, and best yet, it's biodegradable. It's actually even on the National Contingency Plan for the US EPA as a surface washing agent. It's multi-class CUL US and NFPA compliant fire protection, prevention, and suppression agent. And then when I sit there and I start talking to people, and especially when I'm having trainings with fire departments, I always ask the question when we get into this last line: a combustible and flammable vapor and liquid spill mitigation agent. And the question I always ask my audience when I get to this point is, can you name me anything in the fire service currently being used that will work on combustible or flammable vapors? The answer is always silence, because there isn't. Okay, so we're going to see how we are now going to add a tool into the firefighter's toolbox and being able to deal with those types of an emergency. So we're going to start with spherical micelles. Let's have a little bit of a, understanding of what this is. And I mentioned earlier in the NFPA 18A, that section 7.7, okay, this is where we're going to start to get into that spherical micelle stability test. And we're going to learn about that here in just a second. But these spherical micelles are able to encapsulate carbon molecules, both polar and non-polar, your hydrocarbon, again, your vapors as well as your liquids. And they work on a chemical molecular level. When we look at foam, and the reason why foams don't work on three-dimensional fires is because they work on a mechanical basis. They need to cause a separation between the fuel and the oxygen. Okay, we're changing that, and you're going to see just how we're going to do that as we continue on. So to have an understanding of the product, we first need to understand our molecule, how the molecule works. And this is just a real quick animation showing the basic building block, that spherical micelle, and it all starts with our molecule. Our molecule has a polar head and a nonpolar tail. Polar head loves water, wants to be in water. The nonpolar tail fears water, wants to get away from water, does everything it can to stay away from it. So as we introduced it into the fire stream, and we saw earlier, they were pouring it into a tanker truck. Okay, here we are using an eductor. When the agent, these molecules get into the water stream, they create these spherical micelles. There's millions of them. So now when it's coming out of the nozzle or comes out of the sprinkler head in the sprinkler system, all of those molecules closest to the surface of the water droplet, those tails spin out, trying to get away from the water. And I've now put a skin on the surface of each and every water droplet. But yet there's still millions and millions and millions of spherical micelles in each and every water droplet. And just to give you a little bit of a visual, if that water droplet was the size of the earth, those spherical micelles within that droplet would be about the size of a pea. Just to give you an idea. So there's millions of them, and they do serve a purpose. And one of the things that you're going to see as we can continue through, we're going to see just how it's able to transfer the heat and making extinguishing of fires a little bit easier. So the spherical micelle, again, is covered under the NFPA section 7.7, where it talks about agents need to be able to pass this test in order to fall into this category of agent. I also early at the beginning talked about that Annex A 4.3. Why is it important? Because it is the only NFPA standard that currently has any information that refers to or relates to lithium-ion battery testing. This is the first, but yet when you sit there and you start hearing experts talk, it's copious amounts of water. To me, it's a lot of experts that aren't doing their homework. They aren't keeping up to date with the current technology, with the current uses for 21st century extinguishing agents. So here we have an agent that has annex material in its standard, which shows that it's able to work with. And look at some of these independent third-party test organizations. Okay, the Kiwa, the Dacre, the Daimler, how about Deutsch or Bosch? And we got Fraunhofer University, and the list goes on and on of people that have tested, companies that have tested, and companies that have standardized on this as their agent of choice because it works on all hazard classes. They don't need multiple extinguishers to be able to deal with the hazards within their facilities. So when we sit there and watch this lithium-ion battery protection, okay, this is from HCT Europe, showing us, we have a battery that would be in a car. And when they fail, they can be pretty impressive. Okay, now we have an encapsulator agent that's recognized by the NFPA. And there's so many myths that we have to deal with, okay, about them being tested thoroughly, okay, about water is the safest or copious amounts of water, how encapsulator agents, don't help with the toxicity. But yet we have the annex material in A 4.3 because of all the testing that's been done. You'll see this video a little later on, but here again, we have an example of a battery, and we'll see how and why encapsulator agents are able to work. And you'll see, hey, you have a pretty impressive fire going on right there, and how this testing from the time where that gentleman was doing it with the extinguisher and became exposed, these tests now went indoors because what they wanted to do is they wanted to document. They wanted to find out just what was taking place. Why was encapsulator agent able to do it? And we're going to see how when we sit there and talk about being able to encapsulate gases, okay, and making the toxins, as I was talking about with the fire, the soot and the smoke. Okay, we're able to do it with that. Well, what kind of an effect are we having with the gases that are being emitted with these batteries? We'll talk as we go through and continue on in the presentation a little bit about some of the findings that have come from these tests with T.L. Coastal University and some of the others, because these tests started to move indoors. And you see here, encapsulators are able to reduce that HF gas that's being emitted. With our test summaries, F500 in all of the areas where they've sat there and they've tested it, these labs and these schools basically switched over. And they're showing how, here we had 50 liters of water failed to extinguish a battery in one test. Okay, it wasn't able to stop the thermal runaway, but yet they were able to do it with a very, very small amount of the F500. So, as I said earlier, this is the fire tetrahedron. When we talk and we use foams, we're causing that separation. We're causing a separation between the oxygen, the heat, and the fuel. We're really not doing much to get rid of the heat. Okay, and a great example is at night when you're cold. Okay, what do? You grab a blanket, cover up, keep the heat in. What do you think foam's doing? So if we're using foam, okay, to try to put out a fire, and we are able to get a build up enough foam, we're able to smother the fire. If we don't continue to watch that fire, that foam blanket could break down. If that heat hasn't dissipated before that blanket has broken down, you have everything you need for a reignition, a rekindle. But yet when we sit there and start looking at an encapsulator agent, we're going to see here in a slide coming up just how effective an encapsulator agent works at being able to transfer the heat, how it's able, and I mentioned, able to encapsulate those fuels. Okay, and if I'm encapsulating or I have an effect on any one of those, three legs of the triangle, the oxygen, the heat, and the fuel, if I have an effect on any one of those three, okay, I can put the fire out and keep it out. So the unique features, that's 7.7, that spherical micelle stability test. And we also will talk about that burn back resistance. Okay, it's important when we sit there and start looking at those piles of fluff or some of the other class A materials or some of the others, that could have some ability to catch fire again. And many times once they've been sprayed with the F500 encapsulator agent, yeah, they can still catch on fire, but it's going to take a lot more heat to get them to ignite. We look at a large pit fire. And when we look at, and we talk about foam, foam has only 3 application techniques. The techniques are rain it down, bank it in, and roll it on. And a lot of times when I'm talking to people in different industries, and we are talking about foam, I pay attention to the wind, especially when I'm at industrial sites, because if they're, talking about, oh, we're protected by foam and we train with it, I get out to some of these rural areas, different plants, different, recycling facilities and things like that. And I find out that they have some pretty strong winds at these facilities. And if I'm making bubbles, what do you think is going to happen to them on windy conditions? Bubbles are going to go in the direction of the wind, not the direction you're throwing them in. So you will end up losing a lot of your foam or a lot of your abilities to suppress that fire because of the wind, or you may have to get closer to be able to have an effect. And we sit there and we then start looking at the calculations that are required. We got to take and count the, square footage. We got to look at, how or what's burning. Is it a polar solvent? Because if it's a polar solvent, it's going to require more concentrate and a higher flow density than it will if it's a hydrocarbon. So there's some calculations that need to be done to make sure. And then we got to take into account that 15-minute flow rate. Okay, that's covered in NFPA. But yet, use an encapsulator agent, what might take 20 gallons, 30 gallons to put this fire out, and it might take us 15 minutes, 20 minutes, 30 minutes to be able to extinguish this fire. I can have that fire out with an encapsulator agent in about 18 seconds. So do the math. Again, just like I pointed out with the cost on being able, and diesel fuel and a cost of the extinguishing agents with the tires. You have the same thing here. Okay, about 20 seconds, 18, 20 seconds versus 15 minutes or longer when you have a petroleum fire. So the savings can be very huge. And as I said, how many gallons of foams is it going to take? If I need to blanket that for 15 minutes, it's a huge difference in cost, especially with some of the green foams. Because if we sit there and we start looking at, some of the reports and some of the statistics that are coming out on these green foams that are being introduced, okay, we're finding out that, whoa, hey, just a minute, they don't work. Or we have to use 3 to 5 times more, okay? Because they're not as effective. And then the other thing I like to talk to people about when we sit there and start looking at the green foams is please, 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 before you make a decision to switch, do a little homework. Ask for an SDS. Because are you giving up what might have caused cancer for a product that might cause birth defects or other health effects? Let's do a little homework before we just sit there and just automatically go and start looking at these green foams. So when we sit there and start again looking at the F500, the amount that's being, or excuse me, how you need so much less product to be able to extinguish a fire versus what we currently use in the industry, and that's foam or plain water. With foam, you need to blanket. You need to be able to smother. You have to cause that separation. With an encapsulator agent, you do not. Okay, there aren't any special application techniques with an encapsulator agent other than aggressively fight the fire. You sit there and you go on our website and you start watching some videos, you'll see the firefighters or you'll see people applying it. They may change the spray pattern. They may go in to a straight stream. They may go into a power cone. They may widen it out a little bit past a power cone, but they may change that stream pattern. But other than that, there's no special application techniques, just aggressively fight the fire. We talked about those flammable vapors, being able to remove them, get rid of that hazard. Auto accidents or at a refinery, or a recycling center, you have a fuel spill, you have oil, you have things that might contaminate the area or the ground. Again, you can sit there and you can use an encapsulator agent to treat those areas and help to mitigate and reduce those spills, make them less hazardous. And then that thermal runaway. Okay, just as that annex material states, here we have an agent that can stop that thermal runaway. And as we get into this section, you're going to see just exactly why. We're going to start talking about that thermal circuit, that how an encapsulator agent. And again, I'm going to have you think back to that animation, that skin that we put on the surface of each and every water droplet. And as you can see here, we have that water droplet with the skin. All those tails act like a heat sink. They grab the heat and they drive that heat inside of the water droplet. And all those millions and millions of spherical micelles that I talked about, they rapidly absorb that heat. But then they slowly release the heat to the water around it. And in that process, the water never reaches 212 degrees or creates steam. So now, if I do have any people that are firefighters or have any knowledge of firefighters, firefighting, they know that, when we use water, in many instances, we're using water to create steam so that the steam can blanket and smother the fire. Well, now I'm sitting there, I'm changing that. I'm not creating steam anymore. I'm being able to have an effect on cooling rapidly and extinguishing. I'm able to reduce those toxins again. I can't say it enough. I'm making conditions safe, not only for those fighting the fire, but the community, okay, that may have to be evacuated because of a fire at a recycling center. Would be nice to be able to just quickly get in there and put the fire out. And here's a great picture of, again, thermal imaging. It's showing that rapid decrease in temperature. He's using a little 20 gallon per minute. So we're not flowing big water. But as he goes through and he starts spraying, 20 gallons per minute, you can see that color change so rapidly because of just how effective the agent is of being able to take the heat out. And you'll see this little section right here in the A post. It just rapidly cools it and is gone. So it makes a huge difference in being able to. And again, we have
Hazard control.
another video that we see here where they're taking a torch and they're heating up a hood of a car, a piece of steel, and it's heated up to over 1200 degrees. And the problem is unfortunately, the instrumentation that they were using to measure the temperature only went to 1200 degrees. It pegged out, so we don't know exactly how hot it really was. Now you see when they sit there and they start heating it up, that paint on the opposite side starts to burn. And when they sit there and they come along and they use a 3% mix of encapsulator agent, the F500 on the backside, you'll see the second he hits it, the fire's out because he's removed the heat. He sprays just a little bit more, not a lot, maybe about a third of that extinguisher. After he's done it, he comes up to it and he's able to sit there and he's able to put his hand on it. He's taken that much heat out of it. He's able to cool it that quickly. So he's taken it from excess of 1200 degrees down to less than 100 degrees in a matter of seconds, where now he can put his hand and place his hand on it. And that's what we need to be able to do to extinguish our fires quickly. And again, we mentioned foams are not suitable. We have to blanket that, especially if it's in any type of height to it, or if there's any movement to the fire. So the benefits when we sit there and start looking at the Class D metals. Okay, we talked about those Class D metals and how with those Class D metals, the water was split into its two properties, hydrogen and oxygen. Well, as again, we think back to that water molecule, the spherical micelles, we put that skin on the surface of each and every water droplet. So now instead of it being water that comes in contact with that Class D metal and separating and causing that water droplet to separate it, we're now actually working to absorb the heat out of those Class D metals. So we don't see those explosions. We don't see that mag explosion like you would expect if you were using plain water. We're changing how we're able to have an effect on dealing with those types of fires. And when we sit there and we look at this video, I'm going to again pause it, because when we look at the firefighters and they were fighting that fire on the previous video, we saw them. But one of the things that we point out when I show this video, we talk about being able to reduce that soot, reduce those toxins and all the hazards. And I still have a lot of fire taking place in this video. Where did the black smoke go? Okay, where does the smoke go? And I do demonstrations with people and we recreate this because they're just in awe at the fact that, hey, you can still have a lot of fire. And as you can see, the black smoke doesn't come back. I mean, the white mist that you see is not steam. So I go back to that fire at a recycling center, okay? And when you sit there and you start having these large fires and you start having those large plumes of smoke and toxins affecting neighborhoods, affecting communities that require evacuations, wouldn't it be nice to be able to attack these fires quicker, okay, safer, and hopefully prevent people from having to be relocated for days or hours, whatever the case may be, because of a fire at a facility. And then we get into, a report that kind of talks about the reduction in the soot and in the toxins. It was done by Clemson University. And what they were doing is they were using a toluene as their fuel source, and they did a comparison between plain water and a 3% mix of F500. And then we're looking at three things in this particular test. They wanted to look at the light transmission through the smoke column, looking at the buildup and the toxicity of the soot. And they did a series of tests. And again, the fuel source was toluene. And when they did it with a 3% mix of the F500 spraying through that same smoke column, they were able to notice a 68% increase in visibility. The reduction in the soot, 97%. It's a lot less effect on your community. But how about the carcinogens and the toxicity? 98.6% was reduced. It's a huge reduction. You know, that's that much less of an impact you're having on your community. When you look at the soot, downwind, okay, what about the fallout? You know, do people think about that? Okay, here you can have an effect in being able to decrease the fallout that may affect not necessarily the immediate community, but it could affect a community miles downwind. So things we have to and should be considering and looking at. And it talks in here with the conclusion how, you know, with the use of encapsulator agent, you know, along with the vapor reduction experiment, you know, they're talking about that interruption of a vapor phase combustion by inhibiting the radical coalescence into the soot particles. So, you know, where those soot particles are formed, we are actually having an effect. We're preventing them from being able to form. So it makes a huge difference in being able to deal with those. So, you know, let's look at the benefits. Okay, there's been many that I've mentioned. Okay, the reduction in water, the reduction in fuel costs for your trucks. Okay, the abilities to reduce the soot and the toxins and vapors. Okay, the carcinogens, better as far as the health of everybody that's exposed. Big thing, less toxic runoff. EPA would love to be on your scene when you sit there and start having these scenes and you're starting to use these thousands and thousands of gallons of water. And the increased safety. Again, let's look at those man hours on that fire. 420 man hours. Okay, versus 10. I would say that's a much better use of our resources, our firefighters, again, especially on days when it's 100 plus degrees. Okay, instead of having 10 firefighters out there possibly suffering from heat exhaustion and heat stroke and all the other bad things that can happen. Okay, how about we have 2 out there at a time and we rotate them? Okay, we can still use 10, but how about, you know, every 15, 20 minutes, we rotate 2 new ones in there so that we can better utilize our manpower, keep our people safe, keep them healthy, reduce their exposure. We mentioned a lot about lithium-ion batteries. So let's start looking at some of the testing and some of the things and how encapsulator agents work on lithium-ion batteries. And the testing is continuing. I mean, we're not stopping because, you know, every day we hear in the news how, you know, the lithium-ion battery market's changing, it's evolving. They're coming up with new chemistries for lithium-ion batteries and, you know, doing all these things. Well, encapsulator agent is right there with them. We're testing, we're trying to be involved. We want to be part of and show that this agent works. You know, we've got the material, we've got all the previous testing. We want to continue to do these tests. In that report that showed the 3 different agents that was done, and this excerpt comes right out of the Johnson Controls report, where it shows powders were poor. Recommendation, do not use, not recommended. We look at foams, moderate to poor. End results, not recommended, do not use. But then the F500, sufficient all the way across, you can recommend it. And when we sit there and we look at Extinguisher subsidiary, Johnson Controls over in Germany, they're actually marketing fire extinguishers with F500, and they have literature and brochure that states the only effective extinguishing agent that can stop thermal runaway is F500. This is a test because, you know, when we sit there and we start looking at, you know, things that have been done in the past, they've been on a smaller scale. And you see here, this is a larger scale test. It's basically a battery that would be put into a car. And what they've done here is they're trying to test the effectiveness of a fixed sprinkler system, something you would find in a building. And what they've done is, they are causing these batteries to go into thermal runaway because they want to see how effective a sprinkler system would be in being able to extinguish a lithium-ion battery fire. And they're using, again, F500 solution to be able to extinguish it. So it's in the past, we've seen many of our testing that has been done, and they've been on like just individual batteries, not the whole module. And this is pretty much, the entire module. We see the fire growing in size. It's got to heat up because when we sit there and start looking at our fixed suppression systems, most of the time they have heat sensitive heads that will react. So inside of this container that this test was done in, we have to develop enough heat to cause the extinguishing agent to be activated. Now, in just a second, you're going to see the screen go black. As soon as the agent gets released, okay, and starts to extinguish the fire, okay, the screen goes black. It's gone. The fire's out. Your light source, you're inside of a container. Your light source is gone, and all the smoke and all the things that were being released as that battery burned, that HF gas, all those toxins, okay, being released when those batteries burned. Now, there's multiple things that took place in being able to extinguish that battery when they used the encapsulator agent. We talked about encapsulator agent being able to encapsulate flammable liquids. Well, it just so happens the electrolytes in those lithium-ion batteries are flammable. F500 is able to encapsulate it, eliminating that flammable hazard. We talked about the rapid cooling, watching that plate, that steel plate get heated up and then rapidly cooled to where you can put your hand on it. We're able to rapidly cool. If we are able to rapidly cool, what do you think that does for thermal runaway? But the other thing that we're talking about now also is how about that HF gas, all the toxins that were being released into that container when those batteries burned. We're able to have an effect to reduce those toxins and that soot as well. So we're looking at a product that's eco-friendly, okay, fluorine-free, it's biodegradable, non-corrosive. And the big push around the world is to get rid of all the PFAS, all the PFOS and the PFOA foams and all the materials, okay, because of the hazards. And they're looking for an eco-friendly solution. Here it is, okay? I don't know how much harder you need to look. The problem becomes is so many people are used to a product that makes bubbles, that makes foam, that it's hard for them to look at something that doesn't. Okay, and as we continue to work and train people in how an encapsulator agent works and getting that message out to them, we're starting to see some agents, some groups sitting there and start to look at this new technology. But just again, some of the occupational health and safety benefits. These female firefighters battling cancer and all the other cancers from exposures to the foams, and states that are banning the forever chemicals, the PFOA, PFOS, and PFOAs, and the airports. I mean, many airports are affected, especially military bases that used to practice and train with foams all the time. The ground contamination, not only on the base, but around the base, is huge. We've got states that have do not eat deer in a 5 or 10 mile radius around an air base. We've got areas that do not eat the fish because of the water contamination. And these are forever chemicals. They don't go away. And they're bioaccumulative. Well, the big thing is cancer. All the lawyers are talking about cancer. Again, if you really want to take a few minutes, do just a tad bit of research. Look up PFOS and PFOAs and health effects. And you're going to see there are many more health effects other than the cancers that are so publicly talked about. So it just takes a couple minutes to really find just how hazardous they are. So when we now want to talk about how do we get the encapsulator agent into the water, or how do we get the F500 onto the fires? Okay, again, there's many different methods. As we saw in some of the videos with the cars, here is a real good picture of our TKO nozzle. Okay, that's very effective. It's a little 20 gallon per minute nozzle, very little nozzle reaction, very simple to use. Only requires 100 PSI to it. Again, 20 gallons per minute. We'll talk about fire extinguishers and all the benefits and all the different sizes we have with the fire extinguishers. When we sit there and we start looking at it, we have different hose. We have the straight tip. We have a European misting wand, and depending on your need, we're going to work with our customers to make sure that we get them to the right extinguisher or the right tip on their extinguishers for their hazards. And when we sit there and we talk about these extinguishers, we always recommend a 3% solution that's used in it. And here's an example of that European water mist hose. Very effective when we start looking at being able to deal with lithium-ion batteries, Class D metals, and a few others. We find that this is very effective. Good spray pattern, gives you some really good effective cooling when we deal with fires and things like that. Now, some of the other things that HCT offers is absorbent materials. And we work with and have with us a Mirazorb and our Throw and Go. Again, environmentally safe. We try as a company, HCT, to be environmentally conscious. And, we would like to work with others that do the same. And here we're going to have a real quick video I'm going to show about this Throw and Go, how it's eco-friendly, how it's able to absorb your hydrocarbons and being able to have an effect in cleaning up spills that might occur safely.
Hello, my name is Tim Johnson, and I'm the sales manager for a company called Mirazorb out of Olympia, Washington. We are the manufacturer of a Northwest premier product called Throw and Go, which is used as an absorbent to pick up fuel and oil spills in the roadways. Today I want to demonstrate to you why our product is the product of choice for so many. First, I would like to place some gasoline in the bottom of this lid. You'll be able to see how quickly it wicks the gasoline into itself. Now I'm going to put our product uphill from it. And the peat moss has a strong positive charge on a cellular level for hydrocarbons. So it acts like a magnet. And once it's pulled the hydrocarbons and contaminants into the cell, it will not release it again into the environment. As you can see, Throw and Go is rapidly drinking that puddle of gas. It's wicking it uphill and it's sucking that puddle dry very rapidly. As you can see, in a matter of about 30 seconds, our peat moss brought in all of that gas, wicked it uphill, and sucked that puddle dry. Next, I'm going to show you the fire retardant and vapor suppressant nature of our peat moss. Because of the proprietary drying process that we use, our product acts as a wet blanket over flammable fuels and contaminants. Cover that with a fresh blanket of our peat. I'll put a torch directly on it. And as you can see, that Throw and Go will not allow ignition to take place, even though there's a lot of gas underneath that. Next, I'm going to pull this back and get into some of the wet, gassy peat, and I'm going to light a small fire, and then just a little bit of peat moss sprinkled on immediately snuffs out the flame. A couple of huge safety factors there. Most of our first responders, the biggest risk that they have with a fuel spill is a spark igniting an explosive fire. They love the fact that once they put throw and go down over the fuel, now they don't have to worry about that. It simply cannot happen with our peat moss. Secondly, all of your fuels and oils give off a toxic vapor. Our throw and go holds those vapors down so workers don't have to breathe them while they're working around fuel and oil spills. Next, I'm going to demonstrate how our product works versus the leading kitty litter with used oil. I'm going to put a couple of pancakes of used oil on this pan. I'm going to use a leading kitty litter that is available at all your auto parts stores and still used by many for an oil dry. And on the other side, I'm going to reuse our peat moss that's already brought in fuel. So this is a second usage for throw and go. Now, if you've worked with this type of product, you know you have to sweep it around, push it around, do the kitty litter dance, whatever it takes to get this product to pick up. And because it's not a true absorbent, it's a lot of work and it doesn't work very well. This product is actually classified as an adsorbent, meaning the oils and fuels will only stick to the outside of the particles. They're not being brought into the cell. So wherever this ends up after you pick up a contaminant with it, it's going to recontaminate the environment, called secondary contamination or leaching. The other issue with this type of product, if you read the back of the bag, it warns against silica dust, which is in all of your clay-based kitty litter type products. Silica is carcinogenic, causes cancer. They warn you not to breathe the dust. Again, ours is all organic and natural, will not harm the environment, people, or animals. Now, the best part about our product, it's called throw and go because you can throw this down, go about your business in the work site or at an accident scene, come back 10 or 15 minutes later, it's done the absorbing for you. You don't have to sweep and work it, just shovel it up with a flat shovel. Your surface is going to look like that instead of like that, because this is going to go after the oil on its own. It's going to ball it up like that, leaving the surface clean by comparison to this mess. Well, that's all we have for you today. Thank you so much for watching. You can learn more about our environmentally friendly line of products by going to our website at amerizorb.com. Have a great day.
Yes,
Hello.
you can also contact Hazard Control Technologies and we can get you in touch with our local MSR or our local representative that can also help you out as well with getting the AmeriZorb. Now, the other thing we want to get into is our diamond doser. We mentioned that the fixed fire prevention or fire protection system on the sprinkler systems and things like that. The diamond doser is probably going to be one of the best on the market. Or I should say is the best on the market, especially when it comes to working with encapsulator agents. It's one that the HCT recommends because it's very reliable. It's driven by water, so there's no need for electricity or any other power source. The water drives the water proportioner, so it's able to get and introduce the agent into the water stream. And the nice part about it is versus other systems is that the faster the water flows, okay, the more concentrate that the diamond doser will add into the water stream so that it maintains that percentage that the device is designed to be at 1% or 3% for whatever type of hazard that you may have that you're trying to protect. So it's a very, very, very effective and it makes up a complete package, you know, as far as being able to use with. So you get a concentrate tank, your diamond doser, we tie it in with your fire protection system or your water source, and we can sit there and we can protect multiple areas. So we can, again, working with our area managers or our regional sales reps, we can sit there and we can work with you to get the proper diamond doser sized and work for you. And the advantages are there's a wide flow range, okay, so that we can work to get you the most economical solution. Again, as I mentioned, there's no power needed. It works on the water. The concentrate tank can be sized to meet your demand, your needs. So go from hundreds of gallons to thousands of gallons, depending on what your needs are. Very, very minimal maintenance is required, especially when you sit there and start looking at having to do annual checks and research on the systems, much more economical. As far as being able to maintain these water-driven proportioners versus some of the current fire protection systems that are out there. So just a real quick video here about the diamond doser. It's showing us how reliable it is as far as a proportioner and how it works. Again, as I mentioned, it works on water flow. The more the water flows, the more concentrate is added into the downstream. So it starts out with these gear type pump that the water flows across. Those then will sit there and hook to the actual water driven proportioner section. We have that piped in then to the water. We'll hook up our concentrate tanks. We have our water in and our water out. So as you see, as the water starts to flow through, when sprinkler is activated or a water monitor or a hose line is opened up, the water flows across, causes those gears to turn. Those gears activate then the water-driven proportioner portion of the pump, which adds concentrate into the water stream. And as you can see, the flow increases, those wheels turn faster, so that you can maintain that constant pressure. Yes, you can have valves in there so that you can sit there and, doing your testing and doing different operations, you're able to have some control over the concentrate so that if you just want water, you can. But you'll see here how it mixes at the percentage that it's designed for. Okay, your discharge, then you have a flush to clean the system out. And all of these valves and all of these will be marked so that they can be user-friendly is I guess the best way to describe it. So again, a wide variety of flow ranges, that no power needed, your large capacity tanks, so that, if you have to have a large duration, a large flow time, it's an economical way to be able to provide fire protection solutions. So in conclusion, we talked about the versatility of the product and how it works on all these different classes of fires. The fuels, the Class A materials, the Class D materials, the lithium-ion batteries. How instead of having multiple extinguishing agents, we can now have one to deal with all these hazards. When we look at the safety, again, I not only mentioned the safety for employees. I talked about first responder safety. I talked about community safety. All of the safety that you can sit there and you can be providing your community and your area just by using an encapsulator agent and being able to deal with and be able to extinguish these fires faster. I mentioned many times, and I'll mention again, the heat in our current heat wave. Watch the news. How many firefighters are being sent to the hospital on some of these fires because of heat exhaustion? Because of the time. These firefighters are going out and they're spending hours and hours and hours on these fire scenes, but yet you saw in the difference 420 man hours versus 10. Huge difference. As far as safety, as far as effectiveness, and being able to protect all the employees, not only yours, but those that are employed by the community in the profession of firefighting, or basically protect the community. We talked about the eco-friendly benefits, how it's not going to contaminate the soil. And It's not only not going to contaminate the soil, but it's going to help clean it. So if you've got a hydrocarbon spill, you've got oil, gas, you have diesel that's spilled into the ground, and it's sprayed down with F500, it's going to help break that down. It's going to help bioremediate that spill. Okay, there's no PFOS and water contamination. Okay, the hazardous cleanup. You're not going to have to pay for a contractor to come in and dig up the soil because it's contaminated with PFOS and the PFOAs. Okay, and it's going to have a better impact as far as the health of your community. So we see here, again, we have a fire going on, the scar fire, the little TKO nozzle.
You guys ready?
The whole point of this video is as we sit there and we start watching the firefighters, when we sit there and we look, you know, a lot of times, when we sit there and we look at these firefighters going and putting this fire out, when they use plain water, and I point out, especially when I start doing trainings with firefighters on using the agent, you know, how many gallons of water did you use on your last car fire? It's anywhere from 500 to 1,000 gallons. Because when you sit there and they get on a car fire, we open up the nozzle and we don't stop flowing water until the truck's empty. If the truck holds 500 gallons of water, we use 500. If the truck holds 1,000, we use 1,000. Okay, but now here you see the firefighter sprayed for just a few seconds. He shut the nozzle down. He's moving around. He's repositioning himself. And as he repositions himself and he comes around to this other side, because there's the potential for magnesium on that 20 gallon per minute nozzle, that TKO nozzle, there's a selector switch. It goes from 0.5% to 1% to 3%. So because of the potential for magnesium in the steering column, he's changed the percentage to 3%, just to give him a little bit added benefit. You can see the mag glowing and how hot it is down below, okay, and on the steering column. But you're not seeing that huge explosion. You're not seeing that mag come flying out of the car. You do see a real quick flash here in just a second, because as magnesium burns, it has a tendency to form a crust. We break that crust loose, we expose that magnesium, that burning magnesium, to air, and we can have a little tiny flare up, but again, it's not a huge explosion. You'll see when he opens up the car door, you're gonna see in that bottom of just below the seat, you're gonna see some bubbling. Okay, that's magnesium that's actually submerged in a solution of F500. It's under what you may say is water, but it's not. It's a 3% solution of F500. No explosion. Okay, it's still working to cool that mag. Okay, and being able to extinguish that fire. So with that, I will open it up for questions and hopefully we can get you some answers. Okay, well, again, like I started with, welcoming everybody. Again, want to thank you for taking time out of your day to spend with HCT in learning about how we can help and benefit in protecting your facilities or the hazards that you might have within your community. It's been a pleasure. I enjoy doing our webinars, and I enjoy being able to answer the questions that people may have. And, you know, I just want to end because, you know, people have asked me, you know, about, you know, current fire codes, and do I think that we should be looking at them? And, you know, my question and answer to them is always yes. I mean, let's look at the distribution warehouse that Walmart had burned down in Indiana. Now, I'm not sure how long ago that wire or distribution center was built. Was it, you know, 5 years ago? Was it 10 years ago? But let's look at our fire loads. Okay, let's look at, you know, new cars, lithium ion battery cars, you know, parked in garages and parked in, you know, our parking garages, parking structures in different places. And we're putting in all these charging stations, but are we doing anything to improve the fire protection? Okay, look at Walmart again. I'll bring that one up. Okay, when that was built, you know, we probably had nickel metal hydride batteries or nickel cadmium batteries or some other battery technology. Maybe some of the, different things that were in and stored in the warehouse and on the racks was totally different as far as the fire load and the requirements today than that was then. So these structures or these fire protection systems aren't improved on, or there's nothing done to help them to overcome some of the new things that we're storing or we're putting into our warehouses or in our different facilities and our different plants. And just by adding the F500 system into an existing fire protection system can offer you that superior fire protection and give you that protection for years to come. It's not going to be something just for today. It's going to take you on into the future as those fire loads change. So with that, again, I want to thank everybody. It's been a pleasure. I enjoy my opportunities to do the webinars and meet and answer the questions. I hope you all have a great rest of your day or evening. And thank you again for joining us. Any information or anything you require, please by all means contact us, info@hct-world.com. Thank you.